Unlike regular potato chips, every Pringles chip you hold in your hand has almost the exact same shape, precise down to the millimeter. That idea was created in the 1950s by Frederick Bauer, a chemist working at Procter & Gamble. His goal was simple: to make chips that break less, use less oil, and eliminate bags filled with air. With traditional potato chips, around 20 to 30% are already broken before you even open the bag. With Pringles, that number drops to under 2%, thanks to their uniform shape and rigid cylindrical can, which allows the chips to stack perfectly. This same design also allows a Pringles can to hold about 15 to 20% more chips than a typical snack bag of the same volume. Today, more than 500,000 tons of potatoes are used each year to produce over 3 billion cans of Pringles consumed worldwide. The brand generates more than $3 billion in annual revenue and is sold in over 150 countries, offering hundreds of flavors tailored to local tastes and food cultures. In fact, Pringles are made with only about 42% potatoes. The rest is a blend of rice flour, wheat flour, and starch. This mixture allows precise control over crispiness, flexibility, and how well each chip holds its shape during production. After processing, the moisture content of Pringles is reduced to just about 1.5 to 2%, which is significantly lower than that of traditional sliced potato chips. This extremely low moisture level helps Pringles stay consistently crispy for a long time, even while being shipped around the world. So how exactly are Pringles made? Let's step inside the factory. Everything begins in potato fields, but not every potato variety is suitable for making Pringles. The selected potatoes usually have a high dry matter content, ranging from 20 to 23%. This is a key factor in creating a stable starch structure when the potatoes are later crushed, pressed, and dried. Because potatoes grow underground, farmers use specialized harvesting machines. These powerful machines can dig up to 10 inches deep, gently lifting the entire potato plant out of the soil, along with roots, rocks, and dirt, in a clean and controlled process. After harvesting, the potatoes are fed into an automated sorting line. Sensors continuously check size, color, and external shape, while internal inspection systems detect damaged, rotten, or substandard potatoes. During this process, around 5 to 10% of incoming potatoes are rejected. This strict early screening ensures absolute consistency throughout the rest of the production line, where even small variations can affect the final chip's shape and crispiness. After passing the sorting stage, the potatoes are carried along conveyor belts and washed in a powerful industrial cleaning system. Continuous streams of water remove dirt, sand, and remaining debris from the surface. This step is not just about surface cleanliness, but also about protecting the sensitive equipment used later in the process. Even small amounts of dirt or foreign material can damage sharp cutting blades or interfere with peeling machines. In modern facilities, filtration and recirculation systems allow up to 70 to 80% of the water to be reused, maintaining hygiene while significantly reducing environmental impact. Next comes the peeling stage. The potatoes are fed into large rotating drums with rough inner surfaces, similar to industrial sandpaper. As the drums spin, the outer skins are completely removed without damaging the potato flesh inside. Immediately after peeling, the potatoes pass through advanced camera systems that scan and analyze them in real time. In just a fraction of a second, these cameras can detect even the smallest signs of defects or damage. Potatoes that fail to meet standards are instantly removed from the line by precise air jet mechanisms, while high-quality potatoes continue on to the next stage of production. The potatoes are then sliced thin and further broken down by high-speed rotating blade systems. These blades operate at over 1,000 rotations per minute, producing potato pieces that are nearly uniform in size, measuring about 10 to 12 millimeters. The pieces move along vibrating conveyor belts to prevent sticking, while industrial camera systems continuously monitor the flow and remove any pieces with size or structural defects. Next, the potatoes are quickly cooked in hot water at around 185 degrees Fahrenheit for about 2 minutes. This step partially cooks the potatoes, stabilizes the starch structure, and prevents the material from becoming mushy or breaking apart in later stages. After being cooked, the potatoes are mashed into a smooth, uniform mixture. This mixture is then fed into rotating drum dryers, where high heat causes moisture to evaporate almost instantly. During this process, the potato mixture is spread into extremely thin layers that adhere to the surface of the hot rotating drums, then quickly dry into flexible potato sheets. As these sheets leave the drying drums, they break into dry flakes and are ground down once again. This material becomes the core ingredient used to make Pringles, allowing precise control over shape, crispiness, and overall chip quality throughout the production process. The potato powder is then fed into large, capacity, industrial mixers and combined with water, cornstarch, rice flour, wheat starch, degermed corn flour, maltodextrin, and small amounts of salt, emulsifiers, and diglycerides. Each ingredient plays a specific role, from controlling crispiness and binding strength to helping the chips hold their shape during frying. The resulting mixture looks nothing like traditional dough. Instead, it has a texture similar to coarse wet sand, loose, yet cohesive enough to be shaped with precision. The moisture content of this mixture is tightly controlled at around 30 to 35%. The entire mixing process lasts only 3 to 5 minutes, but accuracy at this stage is critical. If the mixture is too dry, the chips will break easily. If it's too wet, they will lose their shape. The dough mixture is then fed into a massive rolling system. Here, extreme pressure, up to around 2 tons, compresses the dough into nearly perfect thin sheets. Each sheet is only about 1 millimeter thick, with extremely tight tolerances, ensuring that every Pringles chip crisps up the same way during frying. The sheets are then stamped into uniform oval shapes. Any excess dough is not wasted, but collected and fed back into the process, keeping waste close to zero. The dough pieces are then sent directly into the fryer. Here, specially designed metal rollers both hold and bend the pieces, forming the iconic curved Pringles shape, also known as a hyperbolic paraboloid. Pringles are fried in hot oil at around 392 degrees Fahrenheit for about 11 seconds. This combination of shaping and frying at the same time allows Pringles to absorb about 20 to 25% less oil than traditional sliced potato chips, while maintaining an almost perfectly uniform crunch. At the same time, the curved shape helps distribute force more effectively when the chips are stacked and transported, making them far less likely to break compared to regular potato chips. After leaving the fryer, Pringles pass through a hot air system that removes excess oil and rapidly cools the chips down to around 104 degrees Fahrenheit. Thousands of Pringles then move through a seasoning chamber, where powdered seasoning is precisely applied to each chip. What makes this step unique is that the seasoning sticks to only one side, the upward-facing curved surface. This design concentrates flavor the moment the chip touches your tongue, delivering a bold and consistent taste with every bite. Every day, Pringles factories use tons of seasoning to create more than 160 different flavors worldwide. From spicy wasabi in Japan and chili lime in Mexico to the familiar rich cheddar flavor in the United States, each Pringles chip is carefully adjusted to match local tastes. In this way, Pringles are more than just a snack. They become flavor ambassadors, carrying the culinary identity of each culture they're made for. And finally, we reach the most anticipated stage: packaging. Thanks to their distinctive curved shape, Pringles naturally stack into neat columns as they move along the conveyor. An automated system then uses mechanical scoops to gently guide each stack of Pringles into the opening of the can. Once each can is filled with neatly stacked Pringles, it moves to the sealing station. Here, the entire sealing process is fully automated. After sealing, the Pringles cans are packed into cartons and loaded onto trucks for distribution. If you enjoyed this video, don't forget to like and subscribe for more fascinating stories behind the world's most iconic brands.